Okay, you guys. So we're just going to look at one long problem right here today. And I do not have that typed up, so I apologize. So you might have to stop the video to write that down or this down. Okay, so, we've got a ladder problem. We've got a ladder leaning against a building. Okay, so I'm just going to draw a little picture. I'm leaning against a building. We've started seeing this picture before. The foot of the ladder is 8 feet from the base, and we know that this is 17. Excuse me, right there, because we know that the ladder is a constant rate. Okay, always look for those constants. We know that this value and this value are continuously changing. Okay, and it's sliding away. So if it's sliding away, it's sliding over to the right. And so if I look at this as a little triangle here, I'm going to call this X, Y, and Z. Okay, so if this is sliding to the right, then that tells me that dx dt is 3 feet, and we are in seconds. Okay, so we want to know how fast is the area, so the area of this triangle formed by the ladder changing at this instant. Okay, so let's see what we can get with this. Okay, so if I'm thinking about the area of a triangle, so I know the area is 1/2 base times height. So in this case, I'm going to say that the area is 1/2 x times y. Okay, so there's a formula that I have. So let's go ahead and let's differentiate it. Okay, so I'm going to have dA dt, and remember that we have to use the product rule here, f prime g, g prime f. So the derivative of the first, the derivative of x is 1, dx dt, plus the first times the derivative of the second, which is dy dt. Oops, and I forgot to put in my y over here, because I did the derivative of the first times the second. Okay, so we need to figure out y, and we need to figure out dy dt. Well, I can figure out y, because I know that leg squared plus leg squared is going to give me hypotenuse squared. So let's see, so y squared is 17 squared minus 8 squared, and you can put that on your calculator. Let me see if I've done it already, and I get that y is 15. Okay, so this is a case where I had to go find out some information. Now, this is a problem, dy dt. I don't know that. So again, I'm going to have to do some more work. So I know by the Pythagorean theorem that I could go leg squared plus leg squared equals 17 squared. Okay, so let's see. Leg squared plus leg squared equals 17 squared. Okay, so there's another formula, and let's go ahead and let's differentiate it, because I'll be able to get a dy dx in there. Okay, so we get 2x dx dt plus 2y dy dt is equal to 0. Okay, and then I usually just divide out that 2. So x, and sometimes you'll see I just even skip that step right there, because I just know that I'm going here. Okay, so let's see, now we should have enough information to be able to figure that out. Okay, so we know at this instance that x was 8 and that dx dt was 3. And at this instance, y was 15, but we don't know dy dt. Okay, so it looks like dy dt is going to be negative 24. And this is making sense to me because it's sliding down the wall, so it should be in a negative. So I always check that those signs make sense. Okay, so dy dt, we're going to reduce that as negative 8/5. Okay, so now I have everything that I need to go back and solve this problem right here, the change in area per time. Okay, so let's go back and we're going to go that dA dt is 1/2. I'm going to put the, okay, dx dt, which we said was 3. And then we had to multiply by y, plus 1/2 x, which was 8, and dy dt, which was negative 8/5. Okay, so then if you go through and you get a common denominator and you do all of that good stuff, you're going to get that dA dt is equal to 161, and this is area, so I've got square feet per second. Okay, so that was kind of a tough one in the fact that you had to come up with those extra values in this problem. Okay, so let's look at the second part. And we're trying to find the rate at which the angle between the ladder and the ground is changing. Okay, so let's think about that. The ladder and the ground. I don't want the ladder and the wall. And the wall's making a right angle right there. So the ladder and the ground is right there. Okay, so let's see how we could go about doing something like that. Okay, so if I have, I'm going to make this a little bit bigger. I have my theta, I have my x. So I need to come up with an equation to relate these, right? They're related rates. So if you think back to SOHCAHTOA, we could use any of those. I could say like that the sine of theta is opposite over hypotenuse. I could say the cosine of theta is the adjacent over the hypotenuse. Oops. I could say that the tangent of theta is opposite over adjacent. So all of those would work. They're good to keep in mind just in case something changed on this problem, this type of problem. But I'm looking at the fact that this is a constant right here. X and Y are variables, but that's a constant with the ladder. So I've got two different variables right here in tangent. Here I have a variable and a constant, variable and a constant. So these two would be preferred over this one because this one's just going to be harder. You got to use the quotient rule. Okay, so I'm going to go ahead and I'm just going to pick that one. So I'm going to say that the sine of theta is y over z. And then I could go ahead and say, well, let me write it like this, since I know that z is a constant. So it looks, now it looks nice and easy to go ahead and differentiate. Okay, so let's put in our value. We know that z was 17. And then let's differentiate both sides. Now, this one is going to be different because we're not doing, well, yeah, I guess we have this variable theta. So we're doing d theta. Well, no, I should put d dt. I shouldn't put d theta there. Bad idea. So just d dt. But I'm going to keep in mind that chain rule now, which we've never used with just a sine theta. Okay, so the derivative of sine is cosine. But we have to use the chain rule here, and we have to say d theta dt right here. Okay. So here we've got 1/17. The derivative of y is 1, and then dy dt. Okay, so what is the cosine of theta? Well, we said that the cosine is adjacent over hypotenuse. So we know that that is 8 and that's 17. So 8 over 17 d theta dt is equal to 1/17. And we already found dy dt in the other part of the problem. Times -8/5. And so we would have that d theta dt is 1/17 times -8 over 5 times that reciprocal. And look at how, oops, this is a 17. That goes away, that goes away, that goes away. D theta dt is equal to -1/5. Okay, so in this case, we have to come up with units. So this is a change in an angle. So this is going to be in radians per second. Okay, that's it.